Well, shall we move on to our Less Wrong posts?
Yeah, let's make our maps a little better, shall we?
Absolutely.
This is the last post in the Physicalism 201 sequence.
Ooh, it's 201. I didn't realize that.
Belief in the implied invisible. This is a follow-up to the generalized anti-zombie argument. He just starts this off by saying, one generalized lesson not to learn from the anti-zombie argument is, quote, anything you can't see doesn't exist, unquote.
I'm about to say something that's maybe a little bit inflammatory, but...
Who cares?
Okay, the default idea of like, oh, this field is completely improvable, so we can just assume it doesn't exist is, true. But he quickly posits a counterexample saying that should I believe in the moment where I can no longer interact with a photon, even in principle, the photon disappears. And he posits a photon that goes flying off in a direction towards a distant galaxy, which eventually will reach a point where we cannot interact with it, even in principle, in any way.
Yeah, well, and as far as the consciousness thing, we won't get bogged down by it, but like, unless the cool EEG experiments happen to pan out exactly as best case scenario, like, we still can't point to the thing like, oh, that's consciousness. But it'd be insane to say, well, therefore consciousness isn't real, or qualia aren't real, right?
Yeah.
There is an invisible thing that we can say we're sure exists.
I was actually just reading yesterday Eric Hole writing about how neuroscience is still pre-paradigmatic because it does not have anything to say about consciousness, which is, the most important thing brains do. And I thought that was a very interesting post.
It's funny. He's the guy that we did that whole episode on, his really shitty anti-EA essay.
Yeah.
But a lot of the other stuff he says is really sane.
Oh, yeah, it's really good. And honestly, I've even halfway come around on some of the things he said about EA.
Well, we'll have to revisit it. I think that his case was just way too... I think he was just attacking the strawiest straw man I've ever seen.
I will agree I disagree with a lot of it still, but there's one or two things where nowadays I'm like, okay, maybe he had kind of a point there.
We'll have a fun talk about it sometime.
I would love to.
All right.
But once we can no longer interact with the photon, even in principle, should we believe that it disappears? Answer is no. That would violate conservation of energy, the second law of thermodynamics, about every other law of physics, and probably the 3 laws of robotics.
Right.
It would imply the photon knows I care about it and knows exactly when to disappear. It's a silly idea. But then the question becomes, if you can believe in the continued existence of photons that have become experimentally undetectable, much like the posited field, why doesn't this imply a general license to believe in the invisible?
This is one of those posts that I can't remember how I felt about it at my first read. I think I probably just nodded along and said that makes sense. But like, in essence, the question you just asked, like, if you're allowed to believe in this photon that you can't touch or interact with anymore, why doesn't this imply a general license to believe in the invisible? Like that's almost a rhetorical question that's so obviously, I don't want to say bait, but like, it's nice that he takes that question that is almost like, I think if it was me, I might have just said, well, because this is a different kind of case, like, duh. And, your invisible dragon in the garage does not fit this case, this kind of case. But he gives a real answer to that question rather than just saying, that's a silly question.
Yeah, I like it too, because also my most likely answer would be, that's stupid, and not to really dig into it, but really engaging in the hypotheticals is really valuable sometimes, because like, okay, but hold on, why? Like, let's actually sit down and think about it and devote some mental effort to it. Maybe I'm just lazier now. I really think that in my 20s, I would have been like, oh, that's interesting. I'm going to put this aside and try to think on it for 5 minutes myself to see if I can figure out, what to do. And now I'm like, look, I got other things to get back to.
Right. Well, I think if it was me, in the heyday of the new atheism wars, I probably would have said something like, for the same reason that you don't believe in the flying spaghetti monster, right? I would have been more flippant. But yeah, I mean, so he brings up Occam's razor to address the general case of like, does adding more things to your model make it less parsimonious? And it's like, no, actually. And he gives a good explanation in terms of Solomonov induction and message length about, if I've got a model that can describe a galaxy really well, and then I learned that there's 100 billion of those, the message and the code length of that delivery is not 100,000 times bigger.
Yeah, you aren't adding any additional rules. You're just saying there's more stuff that follows this rule.
Exactly.
That is the answer for why you don't believe that the photon disappears. He says, if you suppose that the photon disappears when you're no longer looking at it, that is an additional law in your model of the universe. When you believe that the photon goes on existing as it wings out to infinity, you're not believing that as an additional fact. The point is that you aren't believing in any specific instance or galaxy or photon, you're believing in general laws. He says, what you assign probability to is not the photon, but the general laws. When you assign probability to the laws of physics as we know them, you automatically contribute the same probability to the photon continuing to exist on its way to nowhere.
Right. And he calls the thing you talked about a second ago about the additional fact, the difference between belief in the implied invisible, like this, photon that's past our range of ever being able to touch it again, versus the additional invisible.
Yes.
Yeah, so the additional invisible is this like new rule that, well, once it's out of my light cone, then it doesn't exist. That is a new rule, right?
Yeah, and you got to justify those with some reason, some evidence, something.
Right.
Whereas the implied invisible is just a natural consequence of the stuff that you already have a high probability in.
Exactly.
Okay, that's what he ends with, that this is what the implied invisible is, and you shouldn't ever need a separate additional belief about invisible things.
Yep, nailed it. I have a quick fun digression before the next post. I was listening to our episode with Matt and Daniel on GPT-3 yesterday. And
back in the day.
It was fun, and the audio quality would just make you grit your teeth. I think I remember recording that, though. We were all in one room, and it was, kind of echoey or whatever. It was awesome how accurate Matt and Daniel were with the prospect of how good these things are going to get.
Nice.
And I don't think they gave precise timelines, or at least I haven't finished, but they were like, no, soon it'll be doing this. And soon indeed it was. In that episode, we were talking about if anyone ever read the comments on the sequence posts. And I mentioned that because the first comment on this one is by Roku of, the famous basilisk. And it's got a -1 and that's it. I don't want to throw shade, but it's like he missed the point of the post. He's quoting the post here saying, the whole matter would be a lot simpler, admittedly, if we could just rule out the existence of entities we can't interact with once and for all, have the universe stop existing at the edge of our telescopes. But this requires us to be very silly. And then Roku, why? If I believe the universe doesn't exist outside of my future and past light cones, then I don't expect any difference in experiences than you, so I don't really care what the point is of arguing about it. Maybe that's why there was an added section, like bold, in the post, bold added. And he's like, to make clear why you should care, it's not impossible that we launch a spaceship nearly at the speed of light towards a faraway supercluster. This could happen at some point in the future. Do those people just blip out of existence? No.
Right.
So, like, this is a real thing that can actually pay off in important ways.
Yeah.
Outside of our accessibility via whatever, the expansion of the universe is just a really good way to illustrate this point, but it's not the only kind of implied invisible.
I do also wonder, when people say, why should I even care about this? I don't know. Why do you care then? Go have a different conversation about something you do care about.
Yeah, that's fair. All right. Well, then the next one is quantum explanations. Let's crack our knuckles and get ready to dive into quantum physics.
This is the beginning of the somewhat controversial quantum mechanics sequence.
Why do you say somewhat controversial?
A lot of people consider it the worst sequence. Has the least to do with rationality in general. Well, let's get through this post first, and then talk about that. Yeah,
that's fair. Because I was going to say, I think this post on its own has a great deal to do with rationality. Getting into the nitty gritty of, getting into the high level nitty of quantum mechanics maybe doesn't count as, useful rationalist reading or something. But the thrust of this post 100% does. So yeah, you're right. Let's just dive in.
Okay.
He starts off by saying that there's a widespread belief that quantum mechanics is supposed to be confusing. This is not a good frame of mind for either a teacher or a student.
Yeah, and he says, as a Bayesian, I don't believe in phenomena that are inherently confusing, because confusion exists in our models of the world, not in the world itself. Which is really important to remember, that the world is just the way it is. Confusion is always inside us.
Yeah, it's nice to take a step back and realize that if you're looking at something and are just bamboozled and be like, that's weird. It's like, no, hold on. That's the way it is. Let me figure out what is wrong with me that's making it weird.
Yeah.
Or rather wrong with my framing of it or whatever.
Right. Why are my intuitions so off from how the world actually is?
Exactly.
He says quantum mechanics is counterintuitive, but that is a problem with your intuitions, not a problem with quantum mechanics. Skipping down a little bit in the post, quantum mechanics was here before you were. And if you have a problem with that, you are the one who needs to change. And he says, I'm going to consistently speak as if quantum mechanics is perfectly normal, and when human intuitions depart from quantum mechanics, I'm going to make fun of the intuitions for being weird and unusual. I think this is deeply aligned with rationalism in general, that You want to have a model that is the most aligned with reality that it can be, and that means accepting the territory for what it is.
Right. You can't look at the territory and say, no, that's wrong and stupid. I'm going to go with my model instead.
Yeah, I like my map better.
Right. I think it's perfectly legitimate to like your map better, to just running with that kind of framing of saying, I don't need to model the quantum mechanics, even in my own mind, to do basically anything, right?
Yeah, I think he's pushing against the emotional aspect of it's inherently confusing. Like, you can have a map that you're like, okay, I know this map is a simplification of what is actually going on because this is the only level that I can deal with it. But a lot of people do, or at least did, I don't know if this is still the case, say that, no, quantum mechanics, man, it's just inherently confusing. The universe doesn't make sense. His point is that the universe makes exactly the right amount of sense to the universe. You shouldn't go around sabotaging yourself by saying, it's just inconceivable to humans.
Yeah, that's quitter talk. I think it's one of the most unfortunate things Richard Feynman ever said, that no one understands quantum mechanics. And I'm just guessing at the context. It was probably in response to like the letters he got in the mail from people that were like the crazy rantings at physics departments from madmen who have these crank ideas. Mm-hmm. And it's like, if you think you understand it, you don't. And I think he's talking to the general nutcase. But I've seen that quote still just used as a throw around thing for, well, if you're talking about quantum mechanics, you don't know what you're talking about. And it's like, that's not true of people, right. Of some people. It's definitely true of Deepak Chopra, but it's not true of physicists and people who've spent some time learning about quantum mechanics.
And depending on when he was writing, it may have been true of all humans. Like, there was a time where you could legitimately say that if you think you know why some of the stars move in the sky and we call those stars planets, you don't, was a true statement.
Right. Yeah, I don't know the timing of that statement either. So maybe it was accurate at the time, but it's still just an unfortunate thing that people still pull out today.
Yeah,
because everything else that came out of Richard Feynman's mouth, he could point at as like an awesome thing that's still true.
Right. Eliezer talks about like why this is. He says the traditional introduction to quantum mechanics that was being taught at least in 2007 starts by saying that matter sometimes behaves like little billiard balls bopping around and sometimes behaves like crests and troughs moving through a pool of water. Early scientists first thought that matter was like billiard balls, then that it was like waves in the ocean, and then that it was like billiard balls again. And then the early scientists got really confused. Dragging a modern-day student through all this may be a historically realistic approach to the subject matter, but it also ensures the historically realistic outcome of total bewilderment. There was quite a great deal of confusion in the early years of quantum mechanics, and I think he has a good point that there's no good reason to drag people through that. And I kind of feel like the reason people are dragged through that is an emotional commitment to preserving the weirdness of quantum mechanics. A lot like some people seem to have an emotional commitment to preserving the weirdness of consciousness or qualia. It feels mystical and that makes it feel special. And so they want to be like, look, sometimes it's billiard balls and sometimes it's waves. Isn't that crazy? That just infects people. And you can and should eject that right off the very beginning and say, look, no, this is definitely counterintuitive, but we're going to go into why it is what it is. And we are not going to romanticize about how weird the subatomic world is, that it behaves in all these crazy, unintuitive ways.
Yeah. I mean, I do like the shade you're throwing at the consciousness discussions we've had. By I mean, I agree with. I think it's fun that you're doing it. But I think that the difference is that I think that especially people like Liam that we're talking with, they're not holding it up on some pedestal of like this thing is magic necessarily. Like precisely what they're doing is saying that this is a problem that needs an explanation, and to just say, well, it's the neurons is not a good explanation.
Right. I don't have a problem with people that say that. It's just that a lot of times it really feels like there's an emotional connection to the mysteriousness that wants to be preserved. Like when Keats was talking about how terrible it is that we know how the rainbow is formed. I feel like there's people that want to hold on to that for things like quantum mechanics or consciousness. And I understand that emotional desire, but also I think that it is bad and we should fight against it.
I agree. You shouldn't want your model to be confusing and mysterious.
Right.
Yeah.
Then you end up saying how terrible it is that we understand the rainbow now.
Right. And there is a case, too, just to bring us back to the post of the last sentence that he said, that dragging a modern-day student through all the historically realistic approach has the outcome of making them, confused like people back then were. I think there's a lot of fun value in learning about what the scientific terrain looked like at the time that things were being learned.
Yeah.
But that's a separate subject, separate from the subject that's being taught. And
Yeah.
so that really should be taught like in a history of science class, not in a science class. He uses the example of like talking to aspiring young physicists about wave particle duality is like starting chemistry students on the four elements.
Yeah.
That wouldn't be helpful. Like that's a complete waste of time in a chemistry class, right?
Yeah.
But it's totally worthwhile if you're talking about the history of science.
Yeah. It's a good point. So the last few things he says here is that an electron is a mathematically different sort of entity from billiard balls or waves all the time and under all circumstances, in italics, and it has to be accepted on its own terms. So that is a thing we will be seeing a lot in the posts going forward.
Yeah, exactly. He's laid out his approach that like, no, the reality is normal. It can't not be. There's that line that he has in here that, since the beginning of the universe, not one unusual thing has ever happened. Unusual is like the only word there that I could see people quibbling about, because you might say uncommon, because uncommon things have happened, right?
Yeah.
Unusual, you might say nothing mysterious has ever happened. Nothing weird has ever happened. Nature is just nature and on.
Yeah. The next thing he brings up, and one of the reasons that I think this one of the reasons the sequence is viewed less favorably than the others, is that he says, I feel obliged to warn my readers that there are other views which I will not be presenting during the initial stages of this introduction. And then he goes and sticks with his word and only presents one view during the quantum sequence. And I think a lot of people took umbrage to that. They came out saying, look, there's still controversy here. There isn't like a definite consensus on which interpretation is the right interpretation, and you're presenting one of them as if it is the right one. How dare you be so arrogant? First of all, he says right at the very beginning that there are other views, and he's only going to be presenting one of them during the initial stage. So it's not like he was pretending to be giving the one undiluted, agreed upon truth. And second of all, he has an opinion on this matter too, right? He has decided which interpretation he thinks is most likely. So that's the one he's presenting in his, this is how you should teach quantum mechanics if you want to teach it in a way that doesn't maximize Mysterianism and instead makes it as physicalist and grounded as possible. Are you asking him to just go and present everybody's opinion for some reason?
Teach the controversy. No,
right.
I think that the way someone could legitimately complain about that is that the last sentence in the post is, or last line is, embrace reality, hug it tight, which I like a lot. But then if he's going on to say here's reality, but he's only giving out one version, and there's legitimate disagreement, I can see where people might complain about that. But I think that line should be taken with the appropriate caveat that it's like this is one way it could be. I'm going to teach that way. If I'm wrong, go for the actual right one. But the point is, the goal here is to teach you to think like a native of the quantum universe, not a reluctant tourist. And so whatever model you come across, whatever one turns out to be right or most widely accepted, don't think of it as weird or that you're being dragged into it like, okay, well, all right, if you say so. It's like, no, this is the world you live in to the best of your knowledge.
The lesson is supposed to be in how to embrace reality, not in this is the one true answer of quantum mechanics.
Exactly.
And you aren't embracing reality by treating it as mysterious and magical. You're embracing reality by treating it as a physical thing that you have to learn about that just has a way of being.
Totally.
That is the two major reasons for why it is the least popular of the sequences. Which brings me to, I'm not sure about how quickly we want to go through the quantum mechanics sequence. It's supposed to be like, here's an object lesson on how to embrace reality when the initial data that you came across seemed mysterious, and you need a lesson in how to not think like a mysterious, mystical mindset. You need to think in concretes. Since it's trying to do that, rather than giving the one true answer of quantum mechanics, maybe we can go through this a little faster and not focus so much on these specific answers and focus more on the zeitgeist of the posts.
Yeah, I think that would be appropriate. I would even be open to basically skipping these and then just doing a quantum physics episode, maybe. And we could even get on somebody who is, an actually trained quantum physicist, or, whether that's their job or at least they're an expert or something. I'd be open to that idea too. But at the very least, yeah, I think we can probably tackle these more than just one or two a week. We can just run through the gist. Because, all right, here's what I'm going to commit to not doing: teaching quantum mechanics in these sections.
Yes, because I don't understand it anyway.
Right, even after reading these, it could be if I read them slower and worked through them longer. But the thing is, like, I bet they're pretty much as short as they can be, and our summaries aren't going to be able to convey the point of them, right?
I remember when I first read them, I spent a lot of time trying to understand them, and I think I roughly understood most of it. On the reread, I've done the reread of the first three. I, again, spent a lot of time on it, and I still feel like I'm mostly getting it. I know I'm going to get lost in a few episodes' time. I don't think the focus is on knowing the particulars exactly and understanding all the equations. And so, yeah, I also think that maybe just going through these a bit faster and picking up on the general idea of embrace what is real, don't get lost in how mystical it is, would be the thing to focus on as we read these.
We have summarized the entire sequence.
I don't think we can do that.
I mean, I think that sentence sort of does.
Oh, okay.
Yeah.
No, thank you.
But only if we want to skip all of the meat of it. We'll play with our approach to these as we work through them, I think. But that's just something to keep in mind.
All right. So in that case, do you want to read the 3 for the next one?
Yeah.
All right. In that case, for next time, we'll be reading configurations and amplitudes, joint configurations, and distinct configurations.